arise, then a salvage value is considered to mitigate the loss from the product. And for stock out situations, a higher price is introduced, which you all know this is a shortage cost, that means penalty cost for shortages. And the government provide greater subsidy and tax rebate on procurement cost of green products. And whereas least subsidy and tax rebate on procurement cost of non-green product are given to the fund 2. Here you will see in the formulation that the subsidy for green product is always greater than the subsidy for non-green product, and tax for non-green product is lower than the tax or tax rebate on green product is lower than the tax rebate on procurement cost of the non-green product. And the selling price of both type products, carbon emission index and production lot size of green products are considered as decision variables. Here some notations are used to develop the model. The suffix G denotes the green and NG denotes the non-green. Here DG demand rate of green product, DNG demand for non-green product, and PG selling price per unit of green product, PNG selling price per unit of non-green product, and CG procurement cost of green product, CNG procurement cost per unit of non-green product, E0 carbon emission index per unit non-green product, and E carbon emission index per unit green product. Here E is less than E0 because the non-green product always discharge more carbon than the green product. This is here E is a decision variable also, and H is penalty cost per unit shortage of green product, and V salvage values per unit surplus stock of green product. And level of corporate social responsibility activities provided by firm 1 is R lies between 0 and 1, and QG production lot size of green product, QNG production lot size of non-green product. Here production lot size for non-green product is equal to the demand per unit time DNG. And FX probability density function of random variable X, which follows the condition of density function, this is, and FX probability distribution function, and this follows this restriction, and pi is the expected total profit of the firm 1 and 2. So now the demand function, here look this demand function. Demand function of green product alpha A minus beta 1 PG plus beta 2 PNG minus KE plus R by R bar means 1 minus R into X. Here R lies between 0 to 1. Here if R increases, then the partial derivative of del D by del R always greater than 0. So when R increases, the demand of green product increases. That means if you more invest for the society, for upgradation of the society, or any incentive for the society, if you more invest for that, then demand will automatically increase. And if E is lower, then the demand of green product also increases. And the PNG selling price of the non-green product is higher, then indirectly demand of green product increases, and vice versa also holds here. And if price of green product increases, then the demand of the green product decreases. And here alpha into A. Here A is the total capacity of the market, alpha A. And for DNG, there is also 1 minus alpha into A. If we sum this, then alpha A plus 1 minus alpha into A equal to A. So total market capacity is fixed. Here alpha, generally for green product, alpha is higher because alpha depends on the awareness program. For the consumers. If awareness program is more and more people are convinced about the environment, safe for environment, then alpha will be increased. So these two types of demands are considered here for green product and non-green product. And finally, here density functions follows. For sake of simplicity, I have considered here uniform density functions. We may also consider also it as a normal distribution also, but here we consider this as the uniform distribution function. And finally, the cost. This is the part of sales revenue is invested by firm 1 for CSR, and hence the cost of CSR is this. Here, what amount for social responsibility is paid by the corporate firm 1. Here, total earn from selling the item is PG into alpha A minus this. This is the demand of green product DG, PG into DG. And it's certain percent, say R percent. In numerical example, I consider R is 20%. So revenue from the selling of green product, it's 20% is invested for the corporate social responsibility fund. And due to the global warming, the responsible manufacturer abide by the Law of Pollution Prevention Act has to reduce carbon emission from manufacturing processes. As a result, the manufacturer needs to introduce green technology to reduce carbon emission E per unit product that results in higher cost than the initial unit carbon emission E naught. Therefore, the manufacturer invests capital to reduce carbon emission E naught to level E, where E naught is greater than E per unit product emission. So the cost for carbon emissions CMI equal to C naught into E naught minus E whole square. This is known formula. Many authors have used this formula, where C naught is the cost coefficient for green technology to reduce carbon emission compared to E naught. As a whole, the demand is stochastic in nature. The following two cases may arise. And here also, that tax charged by the government and subsidy earned from the government in case of green product is this. This is subsidy. Subsidy is given on the total procurement cost. Total procurement cost is this. And it's certain percent, say S, is subsidy, and tax paid by the farm 1 to the government is T into this. So this is earned from subsidy, and this is paid for tax pollution, for tax for pollution. And similarly, the tax and subsidy of the non-green product is this. Here 1 minus gamma into S, minus 1 minus delta into T, and CNG, this is the procurement cost of non-green product. Here 1 minus alpha into S is less than S because gamma lies between 0 and 1. And 1 plus delta into T always greater than T. From in practice, this type of activities occurs. So if the government offers gamma equal to 1, that means no subsidy for non-green product, and puts large value of, say, values of delta, that means greater tax for non-green product, then farm 2 of non-green producer has to stop his business because its cost for non-green product is more higher than the green product. And then green producer will get monopoly business in the society. Since demand is deterministic in nature for green product, so two cases may arise: stock surplus and stock out situation. For stock surplus, the lot size QG of green product is greater than demand of QG. And here the salvage values B is always less than the procurement cost of green product. Hence the profit of the farm 1 and farm 2 as a whole is this. This is total profit from the green product. And this part also. And here PNG minus CNG into DNG. For non-green product, there is no surplus. That's why other factors are not considered here. Only cost factors are considered here. And this salvage value is considered for green product. And case to stock out situation. In this case, the QG is less equal to DG. And in this case, the shortage cost arises. And then the expected profit function pi 2 is this. This is penalty for stock out situation. And combining these two, here also a good features occurs. When QG is DG, then the profit is maximum. The profit is maximum, that is pi max equal to this. And now QG greater equal to DG implies this term QG greater equal to this. And from here, we can obtain X less than equal to this. X is random variable. And X less than equal to this. And this is denoted by Z, where Z is the inventory factor which represents risk-free inventory level. Substituting the value of Z and combining equation above equation 7 and 8, the profit of the farm 1 and 2 is this. This is the compact form of profit function. Our objective is to maximize pi, considering the decision variable here, QG, E, R, this is the expected value of the total profit. Now our objective is to maximize E of phi, considering PG, PNG, E and Z are decision variable. As the demand is price sensitive, price of green product and non-green product are considered as decision variable, and E is the index of carbon emission. This is also decision variable, and Z also decision variable. That depends upon the lot size of green product. So Z is a crucial factor of this model. And for optimizations, just we have done the partial derivatives of expected profit function E pi, and ultimately we have got here this is one of the relations, integration this. Z is F inverse of R bar PG plus H plus 1 plus T minus S into CG, and this. Here R bar means 1 minus R. So R is also a variable here. PG is variable here. variables, decision variables are PG here, and daily by this relation. And here the optimum values of E equal to this. Here E equal E naught minus Ky K naught R bar Pg minus 1 plus T minus S into Cg. And using del E by del Z equal to 0 and del E by del Png equal to 0, we have this relation. Here Png is a function of Pg, R, Pg and R here. And del E by del Pg equal to 0 implies this relation. So substituting the values of Z, E and Png in equation 17, we have a non-linear equation of single variable Pg. Then solving equation 17, we have optimum values of Pg, Png, E, Z. And then Qg equal to this and Qng equal to this. And now at the stationary points, Z star, E star, Pg star and Png star, the second derivatives of the objective functions constitutes a Hessian matrix. Later you will see the Hessian matrix. I have done the second order partial derivatives here, and after considering a particular case of f of x distribution density function of the random variable x, and this is the uniform distribution function is considered here, and then Z star can be expressed explicitly in terms of these variables, and E star sorry, Png star equal to this and Pg star equal to this. And here so many terms are here. And for feasibility of the model, Pg should be greater than Cg. Selling price of green product always greater than the procurement cost of green product, and this implies this restriction for feasibility of the model. And here Pg star may have two positive roots or two negative roots, or one positive and one negative, or two complex roots, as this is a quadratic function. Sorry. We shall consider the positive values of Pg star and test the Hessian matrix H at point this, where Hessian matrix is this, and by method of principal minors we can show that either this is convex or concave or saddle point. But here for a short method, I have find out the eigenvalues of H, and that determines the character of the function. If the eigenvalues of H are all negative, then our required optimum solution is this, and optimum expected profit is this. And if all are negative, then this is a concave function. That means gives the maximum value. And this probabilistic model can be converted to deterministic model if we put the random variable x by its expected mean mu, then the model of previous model would be converted to deterministic model, and like as the same manner we can optimize these functions. Also here you may question, I have used the simple uniform distribution functions. It likes deterministic model. I agree with you, but if we consider it normal distribution, then we can also find the solution from these equations. Except this, also we may convert these expected functions expected profit functions, we can approximate it as a distribution-free functions, where the functions where the distribution functions depends on only mu, that means mean of the distribution function and standard deviation of the distribution functions. And any type of distribution functions, if we can find out the mean and standard deviation of the distribution from the sample of distribution, then we can easily find a near optimal solutions of this objective function. Now, like as previous manner, I have analyzed these functions. This is the Hessian matrix at stationary point is hello. Hello. Here the Hessian matrix at stationary point is this. And here my initial minors are obtained here. And the above principal minors satisfy the restriction mentioned above. The stationary point provides maximum profit of pi. And numerical examples. To justify this model, I have considered the numerical values. Here alpha equal to 60% as the green products, for green products to attract the customers, the awareness programs, environment awareness programs is more, and that's why the more customers are attracted to buy the green product. In this case, alpha is larger, 60% is considered here, and gamma 90%. This is tax factor, and delta. This is gamma is the subsidy factor for the non-green product, and delta is the tax factor for non-green product. R is the corporate social responsibility index, and A is this B1, B2 is the price elasticity. B1 is the price elasticity of green product, and B2 is the price elasticity of non-green product, and B3 and B4 like this. And CG is the procurement cost of green product, CNG procurement cost of non-green product. And this is this. Then the required optimal solution are selling price of green product is 29.42 and non-green product 19.20, and Z star inventory index. This is inventory index from which we can find the lot size QG is this, and lot size of non-green product is negative here. That means for non-green products, the business should be stopped here. And units E equal to 8.7. Here E naught is 10 units. For non-green product, carbon emission discharge index is 10. And E star equal to 8.7. For green product, E star is reduced from 10. And this occurs due to the corporate social responsibility. As the optimal E star is a function of corporate social responsibility R and selling price of the green product. And here the expected profit from green product is this, and the profit from non-green product is negative. That means this business runs at loss. And example 2, when the market is risk neutral, the demands of the products are deterministic nature. That means here QG equal to demand DG. There is no surplus or stock out. In this case, the values of the parameters are considered here. like as before, as example 1. Then the required optimal solutions are PG star 90.18, PNG star this, QG star this, and QNG star this, and E star equal to 6.02 units. So here also expected profit from green product and profit from non-green product is this. Here the profit of green product is greater than the profit from non-green product. So the effects of CSR activities, awareness programs, subsidy and tax of government on pricing, demands, carbon emission and profits are remarkably observed in the figure 1 to 6 to 16 here. Here price PG and PNG. The blue colored figure indicates the green product case, and the other color indicates the non-green product. When R varies, then price P is increasing, and both are price are increases. And after when R greater than 60%, then the adverse condition arises. And this is asymptotic nature by construction, and for some numerical values, this function PG and PNG shows the asymptotic natures with values of R. And the profit from green product and non-green product versus CSR values are these. Here blue color represents profit from green product and red colors represents profit from non-green product. Here you see when R increases, the profits of green product decreases. So this is the adverse situations. Apparently it seems to me that this is adverse situation, but not, because this graph is drawn, R is only variable, but other factors, PG, price of green product is fixed. But this is not possible. If you invest more for the society, then you have to automatically, you have to change the price of green product. That means it will be high than the earlier case. If PG is higher, then automatically this will also be a increasing functions. Here as PG and PNG are fixed, so the profit is decreases for green product. And as the most investment for corporate society, corporate social responsibility is implemented, so profit is quite decreasing here. That's why profit of green product is decreasing. And the other case, non-green product increases, because in non-green product case, R has no effect. That's why this is increasing functions. And the figure 3, demands rate of green and non-green product versus CSR. Here also R increases, then demand of the green product decreases. As the price is fixed, so the demand is decreases with R. If both are variable, that means if in 2 dimensions we can draw this figure, then this demand will be increasing functions for both variation of price of PG and RG. Because if social responsibility in investment R is increases, then price of the demand of green product decreases, and the demand automatically increases for R and PG also. And figure 4, the carbon emission. This is also confusing to us. Carbon emission versus CSR. When R increases, the carbon emission decreases. This is true, but in another case, just a minute, here carbon emission in figure 8, carbon emission increases when R, just gamma delta, just a minute. Here carbon emission decreases when corporate social responsibility are increases. This is true because more people are convinced by the awareness program, and they will get the incentive if they buy green products. They will get the incentive, and in these cases the more people will purchase the green product, and automatically for green product development the carbon emission decreases with the social responsibility index R. And here price PG and green product and non-green product versus tax factor. If tax is higher delta, then the price of PG decreases, because this tax factor delta increases. This is only for the non-green product, and delta has no effect on the green product. That's why as higher this tax, automatically the green product, non-green demand of non-green product decreases and demand of green product increases. Consequently, the price of green product automatically decreases to attract the customer more. And similar way, the profit of green and non-green products versus tax factor delta is also shown here. This, when delta increases, the profit of green product increases and profit of non-green product decreases, because delta has effect only non-green product. That's why these features occur here. And in figure 7, demands of green and non-green products versus tax factor delta, blue color. This is also this tax factor increases, so demand of non-green product decreases, because the farm 2 would not product more, as the price of cost of this non-green product is higher, so profit will be less. That's why demand automatically decreases, whereas the demand of green product increases, because as the demand of non-green product decreases, automatically the demand of green product will increase. And here carbon emission versus tax factor. If delta increases, then the carbon emission increases. Tax factor delta, when a farm pay higher tax factor, then they automatically will business by he or she, by her or him decision, and they can produce low green product, and that's why carbon emission will be high. And in figure 9, the price PG and PNG versus subsidy factor gamma. Here subsidy is increases gamma 1 minus gamma. Actually in the function gamma has effect only non-green product. But in green product, the subsidy is fixed. That's why the price of a green product decreases, whereas this is increases, slightly increases. And profit from green and non-green products versus subsidy factor gamma, they are also shown here. And demand of green and non-green products versus subsidy factor gamma is also shown here. Time is too short. Okay. Carbon emission versus subsidy factor gamma is also shown here. And profit from green and non-green product versus convincing factor alpha, which depends on the awareness program by the industrialist. Alpha. Here, if alpha increases, the demand of green product increases and demand of non-green product decreases. Consequently, the profit from a green product automatically increases and profit of non-green product automatically decreases. And also demand also follows this type of phenomena with variation of factor alpha. And here carbon emission versus convincing factor. If alpha increases, the demand of green product increases. And as demand of green product increases, so the people are going to follow the greenness phenomena. And such cases, carbon emission automatically decreases. This is quite natural in the nature. And lastly, I may draw a conclusion of this model. The environmental pollution caused by manufacturing industries, transportation systems, and human activities has involved public attention as well as the consumers, industries, and governments. Green products deal with environmental issues through product quality and development arising from the demand cut of customers with new approaches toward environmental values. And sustainable development of green product and its marketing strategy requires the coordination of supply chain members who compete at the same time. Research on coordination for sustainability in the business market has grown up over last 2 decades. And from sustainability perspectives, coordination, collaboration between manufacturer and the retailer adds to sustainability when it makes a positive contribution on the societal level. And in this model, we see that the profit from the green product is always greater than the profit from the non-green product. If we implement the method of marketing and awareness program properly, then we can introduce green product in the market. And then the people of the society will be helpful and a sustainable society will prevail in our society. So I hope the presentation is complete here. Thanks a lot. If you have any question, please.
Anyone can ask directly. I think someone was asking for DOI of this number. Yeah, again raised question by James Dipankar Sen. Please provide the DOI number of this paper. These are the questions.
Reference. Hello.
Sen, sir, are you
References
there?
of this. Hello.
Yes, I'm there.
Uh,
Sir, can you please provide the DOI number of this paper?
DOI number. I will send you two papers. Actually, this paper has been accepted in Journal of Retailing and Consumer Research recently.
Okay.
And also, you will see here, alpha is considered as constant here, alpha into A. In the next paper, I have considered alpha as a variable, decision variable. And this paper is also accepted in Annals of Operation Research. I will send two papers to all of you if you send me the email address, or I will send to Neha, as Neha is co-author with one paper. Actually, I am co-author of her paper. So I will send her, okay? You may collect from her as she is organizer of this program.
Okay, sir.
Any question?
One question from Surbi Singhal. Am I audible?
Yes, yes.
One question is from Surbi Singhal. Surbi, you may ask directly to sir. I think you are asking for some stock.
Hello.
Surbi is there?
Please repeat.
Surbi's
Repeat the
question is,
question.
please again explain the stock surplus.
When the stock surplus, as the demand is uncertain, so there may be two cases arise: stock surplus or stock out. So as there is a risk, so you have to consider both of the case. That's why stock surplus arises if the demand is lower than the stock of the item, then the surplus amount should be sell at a lot at salvage price. This is lower than the procurement cost. But this is common phenomena of a new vendor type problem. Okay. Hello.
It's okay, Surbi ma'am.
Yeah, sir. Now you are working.
Any other question?
Yeah, I am speaking, Dr. Imani. Now,
Yes,
sir,
sir, go
you are
ahead.
working in
Yes, sir, go
corporate
ahead.
social responsible thing in inventory modeling. This is a wonderful phenomena, and as inventory modelers, we should all focus on these areas because they are really concerns too much. Professor Vishwajit Sarkar is also working in these areas. So all scholars from this side, they are looking forward for your kind help and support in this area. So it's very nice to hear you. And we are following your work from very beginning.
Since long, for very beginning.
So all the scholars are a big fan of you. So it's a very good
Yes, sir, sir.
to see live and listen you. Thanks on behalf of this chapter. Thank you, sir. Thank you very much. You may proceed, Himaji.
Yeah. Shivraj sir has already done with his words. So
I want
and
to say something, ma'am.
today we are very
Ma'am.
yeah.
Yeah,
Sarkar
Sarkar,
sir.
sir.
Over to you.
Okay, the matter is that Professor Shiv Shankar Sana is my co-supervisor. So whatever I am today, so it's because of him and Professor K. Chaudhary. So that my learning everything, just like if you just ask me that typing in Word file or LaTeX or Mathematica, MATLAB, whatever, it's everything from his side. So whenever he's coming from his institution and been sitting beside me and checking each and every line, whatever I wrote on the whole day. And then every day he's correcting me that these things is wrong, these things is done, and this whatever I'm doing now for the research, so that each and every aspect is from him. So after near about 10 years, my PhD done in 2010. So after 10 years, I listen his voice through the conference. Even I meet every time whenever I'm going to India. But thank you, sir, for your
Sir,
presentation. Thank you very much.
I am really proud of you and to be a supervisor of such scholars.
both
Yes,
of
sir.
you are wonderful scholars. And one thing I want to ask Professor Sana,
Okay.
now you are working as a principal. Earlier you were a professor. So what is the difference between the role of a principal and a researcher? I think it's much more administration in as a role
Yeah, yeah.
principal.
Actually, I could not manage more time for research now.
Yeah.
That's why you will see my number of publication is lower than the earlier stage. And actually, this is my passion to write something and to publish in a good journal. That's why I am just trying to um, work by hook or by hook or crook. Uh, This is the fact.
We hope much and more coordinations between you and us. And there are several potential scholars here, and I encourage them to work with you with your blessings. Perhaps they will do better. Thanks a
Okay.
lot, sir. Thanks a lot, Sarkar sir. Thanks a lot,
Thank you, sir.
Sada sir. It's wonderful to see you.
Okay.
Okay, Himani, you may proceed.
Yes, sir. So, as said by sir, so today's lecture and actually today's audience, I can see, I can observe that very wonderful, very nice audience, intelligent as well, and well-known faces. Satish sir is there with us. So well-known, very well-known, as well as intelligent, as well as very nice and lovely audience with us today. So the main sir, Sarkar sir, Sana sir, Shivraj sir, Umakant sir was also there, Professor Baron sir. So
Ali Akbar Sheikh sir also there
it's a
every time.
pleasure. Yes, yes, yes. Every time he is also there. So Sharmila Saren ma'am is also there. So uh, it's very wonderful experience with all of you that we are interacting at such a platform. So
Professor Baran is also seen here.
yes,
So,
Pleasure.
yeah. So it's very nice
evening,
to see
sir.
all of you here and interact with. So
Okay.
I'm very thankful to Sana sir also. So now I am requesting to Dr. Neha Saxena to propose vote of thanks for today's session.
Thank you, ma'am.
Over to you.
Good evening, all of you. I'm Dr. Neha Saxena. I feel immense pleasure to take the opportunity to propose the vote of thanks on behalf of ORSIM and the organizing committee. First of all, I would like to thank to our eminent speaker, Professor Shivsang Susana, Principal of Kishore Bharti Bhagini Navideta College, University of Kolkata, to enlighten us with your knowledge, with your valuable lecture on green products. It's the need of this time, and we should pay attention on this line of research. And so one thing I want to tell you that you are such a great personality, and everyone would like to work with you. And of course, my experience to work with you is like learning session for me. I have learned a lot from you, and we all are really grateful to you to grace us. And I would like to I would like to thank Professor Shivraj Singh, the president of ORSIM, to give us the opportunity to organize such an event. And your positive vibes always encourage us and motivate us. My heartfelt thanks goes out to our audience to participate enthusiastically, and especially Professor Sarkar, Professor Baron, Professor Mishra, and to spare your time from your busy schedule and grace us with your presence. And now I would like to thank to the entire organizing team for putting up with this lecture series, and their dedication and hard work has been shown is incredible. I would like to we would look forward to the next lecture on 20th December 2020, which will be delivered by Professor Umakant Mishra. And once again, thank you so much for a productive talk. And I would like to tell you one thing, sir. There are around 8 research scholars sitting here whose topic of PhD is green and carbon emission. In our knowledge, and I can say that they would have listened to your talk very carefully.
Okay.
Yes, sir. Thank you, sir.
Thank you. Thanks.
Sir, nice to see you. And we
Definitely.
hope for much more cooperations and combined work.
Sure.
Thanks a lot. Thanks, everyone.
Thank you,
Thank you,
everyone.
sir. Thank you, ma'am.